This is the chain rule, the formula that makes training neural networks possible. It is given by the sum of a bunch of partial derivatives, and it can be complex at a first glance. However, the chain rule becomes simple to understand once you learn how to think of functions as computational graphs. Let me explain. Let's take the expression f of x. Computationally speaking, we have two variables, the input x and the output f, obtained by applying the function f of x. For the composite function f of g of x, an intermediate node g is added. Each node represents a variable, and each edge represents a computation. For simplicity, let's remove the arrows from the edges. Our graphs are about to become more complex. Let's agree that from now on, all edges go from left to right. Speaking about complexity, let's add one more layer to our computational graphs. If the nodes represent computations, we can weigh the edges according to the derivative of the computation, that is, its rate of change. To compute the derivative of f with respect to x, all we have to do is multiply the derivatives along the path from x to f in the computational graph. What about multivariable functions? Let's keep the number of variables at 2 for simplicity. In this case, we have two input variables x1 and x2 and the output variable f. Both x1 and x2 are connected to f. Okay, now let's add one more layer of complexity, composite multivariable functions. Consider the expression f of g1 and g2, where g1 and g2 are functions of x1 and x2. Here, the two input variables are x1 and x2. The first layer consists of g1 and g2, both are functions of x1 and x2, while the final output variable is f. Now, let's consider the derivative of f with respect to x1. According to the chain rule, df dx1 equals partial g1 partial x1 times partial f partial g1 plus partial g2 partial x1 times partial f partial g2. Let's see the other one, the derivative of f with respect to x2 this time. Again, according to the chain rule, df dx2 equals partial g1 partial x2 times partial f partial g1 plus partial g2 partial x2 times partial f partial g2. Now we can see the pattern. In general, if you want to take the derivative of the node f, which is the terminal node, with respect to the node xi, which is the starting node, you take the product of the weights for each path from xi to f and sum it together for all paths. If you are interested in more about how the chain rule is applied in machine learning, I wrote a book called Mathematics of Machine Learning. It's a 700+ page introduction to linear algebra, calculus, and probability theory from the perspective of a machine learning engineer. Check it out, I'll leave a link in the description. Thanks for watching, and see you in the next video.